we're just going to do part of this token diary literally whilst having breakfast, because Rob is an incredibly busy man working with PwC, and he'll tell you more about what he's doing. But the only time we could get him is first thing in the morning, ahead of him actually having to go and do his high-powered super job at PwC. So, I don't know, just who are you and what do you do normally?
So, I am Rob Allen. I lead the PwC FinTech practice in Australia. I've co-founded a PwC business called Vulcan, which is a blockchain-based business that brings blockchain technologies to our corporate clients in a way that kind of legitimizes much of the crypto technology that underpins it. I'm an engineer. I've been building systems for banks for about 20 years.
You're a financial ninja, are you?
Well, I'm a technologist. And,
you're a technologist?
Yeah. So
I know a lot of techies like being called ninjas. You don't like being called a ninja?
That's the upstart millennial brand of techies, I think.
You're not a millennial?
I'm way beyond millennial.
You think like a millennial, but
I try to think like a millennial. Absolutely, one has to.
I know.
In order to stay in the game. Prior to the banking career, and I've been freelancing and for 20 odd years in that space. Prior to that, I was a military engineer, and I built battlefield computer systems. So I've got a long track record of being. Building systems that need to withstand a lot of pressure, a lot of duress, both in finances and military. And I think that's kind of a really good experience for today's very fast-moving, very frothy, very distracting technology that we're seeing in blockchain and ICOs and all of that.
One of the interesting things that I really liked when we first started talking about this was you mentioned about you'd actually developed a decentralized database whilst in the army, and I mean, I find that fascinating because that was a long time ago. I mean, we're both slightly maturer than the average millennial,
pre-millennial, I like to think.
Yeah, pre-millennial. I love that word. That's it. That's now definitely going on. We're pre-millennials. So, I mean, it'll just be fascinating because I'm sure. I mean, I found it fascinating when you told me the story, and I think others will find it interesting because it shows that blockchain as a decentralized database is not actually new.
So blockchain is real and new in its current form, of course. You know, the Satoshi white paper in 2008 is really the genesis of blockchain per se, but the constituent parts, the crypto technology, the key infrastructure, the hashing algorithms, and the notion of having a decentralized data sharing mechanism across a peer-to-peer network is not new at all. So when I was in the British Army, I led a team that built a decentralized battlefield computer system. And by its very nature, battlefield computer systems have to be fault tolerant. They have to, you have to plan and design for them actually being removed from the network, you know, quite dramatically with quite a lot of force. Battlefield command and control system needs to be hugely fault tolerant because every single node within that network could be removed from the network very quickly. And the rest of the network needs to be able to operate as if that node had never existed. And so you have to build systems that withstand more than the normal latent pressures within the environment in which they operate. And of course, within a military context, that's pretty extreme.
Yeah.
We don't see it, but you know, there's cyber warfare raging day in, day out, 24/7 across the world these days. So it's not really that different. And it's in that context that blockchain was born through Bitcoin, and was designed to withstand that kind of duress. In computer sciences, we refer to Byzantine fault tolerance as a computer sciences problem that blockchain has very elegantly and very gracefully resolved in its decentralized way. And we didn't have blockchain in 1990. We had other ways of doing it, but we still built databases that could be shared across a peer-to-peer network that were encoded and encrypted at a transactional level, and nodes were able to be kind of added and removed almost at will. So, in many ways it was very similar, but if only we'd had some of the technology we have these days. And I'm long out of the military, but
Sure.
I would expect that pretty much every military engineering team these days doing something similar will be looking at blockchain technology.
Right. Interesting. Just in plain English, what is the Byzantine general's problem then?
So this is a computer sciences problem that's been around for decades. In fact, in around 1982, so even preceding me joining the army, but some of my early kind of information technology training, it was very prevalent. It's a problem that is stated as a metaphor, and that metaphor is if you have a group of Byzantine generals that are laying siege to a castle, and they have fairly latent, slow-moving communications between them, and they know that there is a traitor in their midst, but they also know that they have to act in concert to take this castle. How would they do it? How would they trust the information that comes from the majority of good generals when they know there's a bad general in their midst?
Right.
And this was stated very eloquently in this paper, and has been addressed by generation after generation of computer scientists, ever since. And it's generally been addressed through some kind of centralized authority. So if you've got a decentralized network, then how do you validate the activity of the actors within that network? And this, of course, is there to prevent bad actors coming in, hacking, introducing bad data on which poor decisions can be made by the network. So a centralized authority is usually there to validate that, the health of the network. But of course, with a blockchain, there is no central authority by design. So this was something which had to be addressed by Satoshi Nakamoto, and was done in a very, very elegant way by introducing a consensus mechanism through the proof of work. Now, whether you're a fan of proof of work or not, it was, as I say, a very elegant way of addressing the Byzantine general's problem, and it's generally referred to as Byzantine fault tolerance within blockchains. If you have 10 generals dotted around this castle with a mile or 2 miles apart, the only means of communication is via messenger, foot messenger, and you have to trust the information you're getting from the parties around you. That's very similar to a peer-to-peer network. So it's a network of nodes, all peers, which is key here. They're all generals, and therefore they all have similar authority. But they all have to work together given the information that they are sharing within the network. Now, one of those generals may be a traitor and be giving bad information to the other generals about the time that they're going to launch the attack, or the fact that the number of forces they have available. And that bad information will lead the other good generals to making poor decisions, which could then lead to the failure of the attack on the castle. And so that's the nature of that problem.
Right.
And it's not solved in the way that the problem is presented, but it's presented in a way that computer scientists need to think about when they are building fault-tolerant systems.
So when Satoshi Nakamoto created Bitcoin, this was transformative?
Yeah, I think what we had with Bitcoin in 2008, 2009 was a system which by design and by definition, could not have a central authority. So the way that the computer systems had for 30 years before then dealt with Byzantine fault tolerance was to have another node or a human authority that checked all the data to make sure that it was correct. And big companies like Oracle and SAP have made a lot of money out of building systems like this over the years. With Bitcoin, where you are decentralizing, disintermediating, and distributing the computer technology across a wide network amongst actors that you don't know and never will know, and therefore you never can trust. How do you then create a system that is fault tolerant in a Byzantine way?
Right.
And that was done through the coding of the consensus protocol, which we refer to as proof of work. Right. And that means that every single node on the network that needs to participate or wants to add transactions into the blockchain need to demonstrate an amount of effort that proves that they have worked for it. That's what proof of work is. And that is done in an incredibly elegant way through use of crypto technology to ensure that the nodes are trustworthy in an entirely trustless network. So in the early days of Bitcoin, any one of us could download the code onto our laptops and set ourselves up as Bitcoin miners, just chugging away on our laptops. Of course, we're way beyond that now with almost supercomputing power within data centers doing the mining. But it was designed in a way that we could do it on our Raspberry Pis or on our laptops, and you and I could be mining away on different sides of the planet, not knowing that we were actually part of that network and not needing to trust each other. But if you mined a block and added it to the blockchain, there was a way that proved to me that you'd done it in a trustworthy and validated way.
So what do you think about the blockchain in general in terms of where it's at and where it's at in terms of its overall development, and especially, I guess, within a corporate environment, just in general terms? Do you think it's ready?
Ready for what? So blockchain has become just an all-encompassing word which is pretty meaningless now. The technologies are diverging still at a rate that is increasing. So you've got the blockchain, so the Bitcoin blockchain, and all its derivatives, all the altcoins that came off it. So it's open source. Anyone can create a new blockchain and tweak a few parameters and create, tin coin.
Mm-hmm. That wouldn't sell very well. I think
Rob take it for the breakfast.
No, I don't think they would. There'd be a lot of tin coins would be needed. Rob coins, that'd be exchange rate would be fantastic for those.
They're on Polonix today.
Yeah, exactly.
Check them out. So you've got all that, what they refer to as UTXO style blockchains, the original distributed ledger, transactional basis. Then Ethereum came along and put all this wonderful smart contract programmability on top of this distributed ledger, which really fired the imagination of millions of people around the planet. So that's driven all the interest and the hype over the last 18 months to 2 years. In addition to that, the enterprise aspect and the corporates have got involved. Ethereum is still early days. It's still really quite nascent as technology and not enterprise grade. But that doesn't mean that the underlying technologies aren't valid, and it's caused the likes of the R3 consortium to come together, so 70 plus banks investing in and looking at the technology for specific financial services use cases. You've got a similar consortium forming around InsurTech. You've got the big companies that raise lots of money, like Ripple and Digital Asset Holdings, who are investing tens of millions of dollars into building this technology. There's a lot of focus and a lot of very bright minds looking at it now. Many startups are addressing blockchain specifically, but And then there's Hyperledger, which is a Linux Foundation project which brings together the best of all of this stuff and tries to kind of stitch it together into fabric which is appropriate for use at an enterprise level too. So we're still diverging. All this technology is kind of within a blockchain. Absolutely. But that doesn't mean that the kinds of investment, that's the ICO, or the token sale rather, craze that's going on in the last few months is crowdfunding all this effort at a startup level. So whereas the enterprises, the big corporates have got the investment budgets to invest in this, and you may argue, and I argue as well largely, that they're probably not best placed to do it, but it's bringing the argument on, it's bringing the debate forward. The hungrier part of the spectrum, the startups, the entrepreneurs, the fintechs that actually see that they can be the next Facebook, they can be the next eBay, they can be the next Amazon, using this technology, is generating a lot of interest, and crowdfunding those people through token sales or traditional venture capital raises is the way to do that. And that's driving this forward at a rate that is unprecedented. Blockchain's only, the Bitcoin blockchain's only been around since 2009. Ethereum's only been around for about 3 years. This is accelerating technology that is being driven by other megatrends like cloud-based technology, by machine learning, by mobile, by the millennial thirst for technology and doing things in new ways, the erosion of trust in the trust organizations of the past, previous generation, pre-millennial banks.
Lovely word.
So all of these things are converging at this point in time, and it's driving some incredible innovation, and that's what we're seeing happening.
So what appealed to you about our project, about the Veredictum project, being looking towards acting as a sort of a technical advisor for us at a very high level?
So many things, apart from the CEO, of course. No, it's something new and fresh for me, but digital media rights and that kind of use case has been mooted since the early days of smart contracts, which is only, albeit a couple of years ago, 2-3 years ago, but it's something which is a real world problem. And many of the applications and use cases that are being touted around for blockchain are either pie in the sky or a way off, or it's being used as technology looking for a problem. It's a silver bullet to everything. World hunger and world peace. What Veredictum are doing is a very real problem for a very specific sector, with, in my view, an almost immediate return. Because it's a real problem, we get this right, there is going to be an instant and immediate kind of positive feedback within that problem statement that you're seeking to address. So many of the financial services kind of use cases like trade finance or post-trade settlement or even things like supply chain require a lot of people to work together and move the technology forward. I think what Veredictum are doing and can really do is address this very specific problem statement in a way that makes a difference, and that's why I like fast returns. I like technologically, I like to see things being delivered. I've spent a lot of my life delivering big programs of work that are taking 3 or 4 years to get to conclusion, and then another 3 or 4 to get benefits realization. We're not living in that world anymore. We're now living in a world where you can make a well-engineered solution using the right technology can make a big difference very quickly.
Everybody expects it to happen in a heartbeat.
But it won't. But we're talking about a 12 to 18 month time frame rather than a 5 to 8 year time frame.
Absolutely.
And that's something which very excited about getting involved in. I love the gamification aspects as well. I love the double-sided market aspects of it as well, which is what platforms and platform scale are all about. It ticks all the boxes for me.
What sort of problems do you think we might experience, given where the technology is right now? I mean, and not just us, but it's going to be every party, I guess. What sort of problems do you think?
Well, technology changes, and every technologist, every computer scientist will tell you they have to kind of relearn it used to be every 5 years, and then it was every 3 years, and now every 18 months. And I think most programmers these days are just
Is
so
this actually
flexible.
Allen's law?
I think we could call it Allen's
Because
law.
Moore's law is always about computing power doubling every 18 months, and you just mentioned that magic 18-month word. This is Allen's law.
I would like to think that.
Right. Okay. Officially, it's Allen's law. Okay. Officially.
But the ability to relearn, to refresh, to change, to pivot in startup language away from one programming language to another, using new tools, is a very particular skill that programmers have these days. The other thing that we have these days is that kind of aspect of abstraction away from the technology. So if you understand and if you accept that the underlying technology is shifting, and it is, Ethereum in particular has a way to go before it becomes enterprise grade. That doesn't mean that it shouldn't be used, and it shouldn't be used in such a way that is protected. But if you build an abstraction layer on top, which enables you to have a kind of a service alignment, a customer centricity, this double or multi-sided platform which enables producers and consumers of content to actually interact. This is what platforms are all about. That abstracts away from the actual blockchain, the distributed technology that sits underneath. And therefore, if a business has well engineered its stack, one should be able to, swap out a blockchain or put in another blockchain if needed further down the track. And that gives a business longevity, it gives it scalability, it gives it options. But it doesn't impact the users of the system.
Are you seeing sort of interoperability coming through between blockchains?
That's a big thing. Yeah, so there are a number of organisations that are specifically looking at interoperability between blockchains. There will be no one chain to rule them all, unfortunately. But that's not a bad thing, because we're seeing with R3's Corda a very different type of distributed ledger being built. They're very clear, it's not a blockchain.
Yeah.
But it's specific to financial services use cases where clearly they don't want to be disintermediated, which is what the blockchain problem statement was originally, the Bitcoin one. So, but that doesn't mean that they shouldn't be able to interoperate. And there's a lot of interest in defining protocols that allow this to happen. Yeah. And we're seeing things like Blockstream's Lightning Network and side chains and drive chains and something chains. There's plenty of very, very bright people with PhDs and doctorates and master's degrees focusing specifically on this area, because I think this is where it scales. This is where you get a world computer, because this is when all the blockchains start to. It's a bit of a Skynet vision of the future as well, unfortunately, but. That and plus machine learning and and platform technologies.
You just feel it's all coming together, don't you? The IoT, AI, everything. Mobile devices, and of course, I mean, none of this is going to be possible without us actually having breakfast. So
breakfast is the start.
Breakfast is the start.
I'm sure
I think
Douglas Adams said something like that once.
Yeah, I'm sure he probably did. But I think we need to celebrate Allen's law officially and finish our breakfast.
Well, that tends to zero, doesn't it? So,
that's right. So the breakfast tends to zero, does it?
Breakfast will tend to zero. Yeah.
Look, Rob, I really seriously appreciate you getting involved and actually taking the time out to have Brekkie. I know the breakfast is going cold because you've given some real insights.
My
that
cold
I think
it will taste just as good.
I'm sure it will do. Rob, thanks. Just really appreciate it, man.
Thank you.